Hello, this is Dr. Phil Rosenkrantz again with EGR 403 Online. This is our 7th presentation. It's about Chapter 5, Present Worth Analysis. If you go to slide number 2, you can see that we're getting into the first of our analysis methods, and you'll notice a similarity in this section when we go through chapters 5 through 9, that we're dealing with similar problems, but looking at different ways to analyze the solutions. So I'm going to talk about that on slide number 3. We've already covered the concept of equivalence. That'll be important. We've looked at different types of cash flows and then the different kinds of compound interest factors that we have for different situations. Now you're going to see how we're going to apply those for each of these analysis techniques. In this particular chapter, there's kind of 3 main thrusts. The understanding of economic criteria, and that will be paralleled in every chapter after this. Then, how do we apply the present worth techniques, and that's specific to this chapter. And then finally, I'm going to cover assumptions in solving economic analysis problems. Now, that could have been done next, before going through the criteria and the techniques, but it's a toss-up, and I'm going to do it at the end and follow the same flow of your chapter. So go to slide number 4, and we're going to start talking about the decision-making criteria. There's 3 criteria that you'll find we're concerned with throughout this whole course. One is for fixed input situations, where our goal is to maximize benefits or other outputs. The second is fixed output situations. When we have a fixed output situation, our goal is to minimize our costs or other inputs. And third, when we have inputs and outputs that vary, our goal is to maximize the benefits minus the costs. And you'll see how that's interpreted in each chapter. Our first step when we're working on a problem or to analyze alternatives is to decide which of those 3 categories applies, because then we know which criteria we're working toward. Now, to emphasize this, if you'll turn to the back inside cover of your text, it'd be helpful to have your textbook handy for this whole presentation and for the next one as well. But if you've reached for your text and you've opened up to the back inside cover, you'll see that there's an entire page devoted to economic criteria. And the first one is present worth. And that's what we're covering in Chapter 5. The one right below that is annual cash flow. That's what Chapter 6 is all about. And each one of these is covered in different chapters. So anyway, this economic criteria concept is really important. Go to slide number 5, please. We're going to talk about this some more. The fixed input situation is where the amount that we have to invest is fixed. No matter what alternative we choose, we only have a certain amount to invest. So our goal or criteria to choose the best one is the one that maximizes the present worth of benefits. And likewise, for fixed output, here we have a situation where the amount of the benefit is fixed, or we have a fixed outcome. Now our goal is to achieve that with the least amount of investment. So our criterion is to minimize the present worth of costs. But often, and probably more often than the other 2 cases, we don't have a fixed amount we're going to input, and we don't have a fixed output. And so when that happens, our goal is to maximize the difference between the present worth of benefits and the present worth of costs. And we call that difference the net present worth. Let's go to slide number 6 for examples. If we have a fixed input situation, that might be where we have $150,000 budgeted to purchase raw materials. So our goal would then be to purchase the most we can with that $150,000. Get the most return, the biggest cluck for our buck, so to speak. Fixed output alternative B, is where we have a fixed outcome or a fixed benefit that we're trying to achieve. For example, let's say that we're trying to purchase 20,000 feet of buildings space for a manufacturing facility. Now, why 20,000? Well, we've done our facilities layouts. We know what equipment we're going to be putting in. We know how much office space we need, and we need no more than a 20,000 square foot facility. So, if we look at alternatives, we'll be looking at alternative ways of obtaining 20,000 square feet, and our goal is to get that for the least cost, and so we want to minimize the input. And finally, case C, neither input nor output fixed, we might be looking at different rental properties. They're going to have different costs, they're going to have different benefits because they might have different rents that could be charged. So our goal there is to maximize our profit, or net present worth, the present worth of benefits minus the present worth of costs. Well, it may seem like I've beat this criteria thing into the ground, but it's very important. We use this concept over and over in each of the next, this chapter and the next 4 chapters, and so we need to make sure that it's clear. So let's go to slide number 7 and start talking specifically about present worth analysis. In present worth analysis, what we're doing is we're essentially bringing all of our cash flows for benefits and costs that we project into the future, we're bringing those back to the present time, calculating an equivalent present worth, and then comparing those. There are some situations we need to consider, though, and the first major consideration is the analysis period that we're using. We have 3 different cases of analysis periods we're going to cover here. One is where the useful life of the alternatives that we're dealing with are all equal, and they equal the analysis period. The second case we're going to look at is where we have alternatives that have different useful lives, some of which may be different than the analysis period. Finally, we're going to look at the infinite analysis period case, because that becomes useful at times. Let's go to slide number 8, and we'll start talking about a situation where we have useful lives that equal the analysis period. I'm going to do this by talking about example 5-1 in your text. You're welcome to turn to that if you like, but in this particular example, I have most of the relevant data right here in the presentation. We have a 5-year project. There's tooling and equipment that will last for 5 years, and we're going to calculate the present worth or net present worth over a 5-year span. That's our useful life. And for this example, we'll make it real simple. At the end of the 5 years, the salvage value of the equipment will be 0. We're going to just junk it. Both alternatives in this case cost $1,000. And you'll see that alternative A, it costs $1,000. So in year 0, it has a p-value of minus 1,000. And then it has a benefit of $300 a year for 5 years. So that's a nice uniform series. Alternative B, same thing, $1,000 cost, but its benefits start out a little higher and end up a little lower. Starts out at $400 and goes down $50 a year for 5 years. Let's go to slide number 9 and go through how we would solve this problem using present worth analysis. Well, we've established here that we have a useful life and an analysis period that's 5 years for both alternatives. And when that's the case, it's real simple. We're just going to find the present worth of the benefits and the costs and compare them. We have a fixed input because they both have $1,000 input. If they had different inputs, then we couldn't say that. But here they have fixed input. Therefore, our criteria is to maximize the present worth of the benefits. So we just need to calculate the present worth of those benefits And for the uniform series, it's pretty simple. 300 times the P over A factor, and we have a $1,230 benefit. Let's go to slide number 10. Now we have alternative B. This one is a negative gradient. We're still going to find the present worth. We need to make some calculations. If we decompose that negative gradient into a uniform series and a pure gradient, then we have a uniform series of 400, and we subtract a arithmetic gradient of $50. And if you look at the calculations there, we end up with a present worth of benefits of $1,257.65. Go to the next slide, number 11, and we can see here a summary. We've got the alternative A benefit $1,230, and B was $1,257.65. So according to our criteria, alternative B is preferred because it maximizes the present worth of benefits. Now you'll notice, if you go back and look at the cash flows, that each alternative provided the same total cash flow, but alternative B provided it sooner, and that made the money available to the company sooner, so they got more compounding in their favor. And that's why alternative B came out ahead. Now that illustrates a principle of this course that is very important, and that is that money now is better than money later. Because if you have $100 now, you can invest it and get the interest. If you get $100 later, it means somebody else is investing it and getting the interest during that time. Let's go to slide number 12. There's several other examples. We're just going to breeze through these examples, but these examples have the analysis period and the useful life are all the same, but they illustrate a couple other applications of present worth analysis. In example 5-2, that's on page 170 of the current text, we have a situation where one alternative is a two-stage construction project. Well, this illustrates the beauty of present worth analysis. So you can compare alternatives that have different construction stages. All you're going to really do, in this case, we have a fixed output situation, so we want to minimize the present worth of cost. And so we use present worth factors to find the present worth of the second stage of costs and benefits, all at time 0. And now we have two numbers, one for each alternative, that we can compare. So look that over for its subtleties, and you'll see the advantage of the present worth analysis. Example 5.3 is a situation where now we have salvage value included. It's a fixed output situation, so we want to minimize the present worth of cost. And we use the present worth factors to find the present worth of salvage values. And the salvage value is a negative cost or a benefit. It depends on how you want to look at it. In chapters 5, 6, 7, and 8, you can look at salvage value either way. You can think of it either as a benefit or as a negative cost. But later on, when we get to benefit cost ratio analysis, you'll see that we have to treat it as a negative cost in order to get a valid analysis. But for now, you can look at it either way. In example 5-3, the operating and maintenance costs were assumed equal, so they were left out of any calculations. There wasn't any data given. But you can see the present worth of the costs based on the salvage value. And going on to example 5-4, here we have neither input nor output fixed, so we have to maximize the net present worth. And again, we have salvage value. This problem is just a little bit more complicated than the others, but the principle is the same. We take all of our cash flows, with the benefits being treated as positive and the costs being treated as negative, and find their present worth and find the resultant net present worth. Now let's go to slide 13. Here we have the case where we have useful lives that are different from each other and or from the analysis period, and we're going to build on example number 5-3. In that example, we had Speedy, the alternative, had a 5-year useful life, but now we're going to set Allied up with a 10-year useful life, and if we do that, we find that the present worth for the Allied alternative is now $1,435. Now if we compare those and we want to minimize the present worth of cost, we would pick Speedy. But if we have two alternatives with different useful lives, is it proper to compare the present worth or benefits or cost directly like that? Well, the answer is no, because in this case we have 5 additional years of benefits for Allied that would be totally ignored. So how do we handle that? Well, we're going to make a couple of assumptions. One is we're going to require, say, as an example, a 10-year useful life or a 10-year analysis period. And so for Speedy, in order to get 10 years of useful life out of a 5-year alternative, what we're going to do is we're going to purchase new equipment and tooling a second time. We're going to do it once at the beginning, and we're going to do it again in year 6. And we will assume that we're going to junk the old equipment and tooling. If there's any salvage value, we'll take advantage of it. But we're going to repeat the investment. And then that gives us 10 years of useful life for the Speedy alternative. Let's go to slide number 14. If we calculate the present worth of cost over a 10-year span for Speedy, that comes out to be $2,325. Now, Allied is the preferred choice. So it's important that we have a common analysis period for all of the alternatives that we're comparing. Let's go to slide number 15 and talk about our techniques for dealing with unequal useful lives. We have the repeated project policy that is used. It's an assumption where we can use the same costs and benefits and repeat a project at the end of its first useful life and extend the analysis period. And we can just keep repeating those projects as much as we need in order to get the analysis period we want. That may be a little presumptuous to think that we would be able to find the same equipment in the future and it would have the same costs and the same benefits. However, even though we don't know exactly what those costs will be, the assumption gives us a much better analysis than if we don't do that. The least common multiple technique is a way of aligning project useful lives with an analysis period. And that's where we repeat each alternative so that we end up with the same analysis period for all our alternatives. So for example, if we have one alternative with a 3-year useful life and a second alternative with a 4-year useful life, then the least common multiple is 12 years. So if we made 12 years our analysis period, we would have one project where the repeated project policy would have us reinvest 3 times, and in the other we would reinvest 2 times. Let's go to slide number 16. And another way of dealing with the unequal useful lives is to establish a terminal year. Sometimes the least common multiple method is unrealistic. The example you see here is, what if one project has a 13-year useful life and another is 7? The least common multiple is 91. Well, that may not really be anywhere close to reality. So instead, we can pick a terminal year and then repeat all projects that expire before that terminal year. But once we get to the terminal year, we will truncate all future costs and benefits that would happen after the terminal year, with maybe the possible exception of a salvage value. Let's go to slide number 17. Our last method that we're talking about here is when we have infinite analysis period. When n equals infinity, we have a nice relationship that the uniform annual cost is equal to the interest rate times the principal, A equals IP. You can rearrange that and find that P equals A over I, and if you need it, I equals A over P. Now, when we have a very long analysis period or an infinite analysis period, this assumption really simplifies problems because we can use those nice, easy formulas. In example 5-6, that example is where this relationship is used, and by assuming an infinite analysis period, using the P equals AI formula simplifies the calculations. And I'm not going to go through that example in detail, but you can explore it on your own. Okay, so I've just talked about how to deal with the useful life issue with present worth analysis. Let me re-emphasize that with present worth analysis, that's the big thing. Dealing with the useful life issue and making sure that you're comparing alternatives with some kind of a common analysis period or equal analysis period. The third topic in Chapter 5 are assumptions in solving economic analysis problems, and this won't take very long, but these apply to the whole course, and you'll see how these come up from time to time. One assumption, the end-of-year convention, we've talked about before. And basically, our cash flows for future values and uniform series all come at the end of the period, as opposed to in the middle or the beginning of the period. The second viewpoint is that we're talking about the entire firm. We're not talking about when we're trying to analyze a project. We're not talking about just analyzing it all by itself. We're looking at it in the context of how it contributes to the profitability of the entire company. The third assumption is that of sunk costs. And that is that money spent prior to the project period has no bearing. Now, let me illustrate that because this one can get rather personal. Think of a time when you might have spent some money on something, and because of that decision, it influenced you on what you did with that investment or whatever it was that you bought, and then it caused you to make a decision that maybe wasn't wise. For example, I had a car. This has happened a number of times where it had a major engine trouble, so we'd spend $3,000 or $4,000 to rebuild an engine or to do some major repairs. And then 6, 8, 10 months later, here I am facing another major repair. And so I'm thinking, gee, I better fix this car because I've already sunk a lot of money into it and I need to get my money out of it. And I'd make the second repair only to have it last a very short period of time, and I end up junking or trading in the car. The reality was that the money I had spent on those old repairs really didn't have that much to do or any influence on the car and its economic viability from then on out. But we get hung up on those sunk costs. Here, in this course, money that's been spent prior is ignored. We're only looking at the impact on the present and the future. Finally, we're looking at the concept of, or the assumption of borrowed money, and that is that all the money we're using has a cost, Money coming in, we can earn interest on it, and money going out, we're paying interest on. Finally, we've made an assumption so far that prices are stable, but we really should not assume that. There is an effect of inflation, and I'll be teaching you a little bit on how to deal with that later on. Finally, income taxes. We've been ignoring them so far. We'll ignore those clear up till Chapter 11, and then we'll include that for realism's sake. So anyway, that's the end of Chapter 5, and thank you very much.